These minerals are categorized based on their chemical composition, and each category offers its own unique set of challenges and rewards when you're out in the field. Silicate minerals. Silicates are minerals that contain silicon and oxygen, typically in the form of a silicon-oxygen tetrahedron. About 90% of the Earth's crust is made up of silicate minerals, so they are abundant and can be found almost anywhere. When digging for silicates, you're often searching for precious gems or metals like quartz, feldspar, mica, and talc, as well as more valuable gemstones like garnet or tourmaline. Quartz is one of the most common silicate minerals, and its crystal structure allows for easy identification. It's often found in regions with granite rock formations. Feldspar is a group of silicate minerals often found in igneous rocks like granite and basalt. Mica has a distinctive, layered appearance and is often found in regions of metamorphic rock. Mining for silicates involves careful excavation, as many of these minerals are embedded within other rocks. You'll need tools like chisels, hammers, and pickaxes to break open rock formations and carefully extract the silicate crystals. Gold panning is sometimes used for extracting silicates from stream beds, where the minerals have been worn down over time. Non-silicate minerals. Non-silicate minerals don't contain the silicon-oxygen tetrahedron structure, and although they are less abundant than silicates, they are still valuable in various industries. Non-silicates are classified into several groups, such as carbonates, oxides, sulfides, halides, and native elements. Carbonates. These include minerals like calcite found in limestone and dolomite, often used in the production of cement and in agriculture. Oxide. Minerals such as hematite and iron oxide and corundum, which include sapphires and rubies, fall into this category. Sulfides. These minerals are crucial for the extraction of metals like copper, lead, and zinc. Galena lead sulfide and pyrite iron sulfide are common examples. Halides. This group includes minerals like halite rock salt and fluorite, which have industrial uses. Native elements. These are minerals that consist of a single element, such as gold, silver, or copper. They're often found in their pure, metallic form in natural deposits. When exploring for non-silicates, the approach often involves locating specific geological formations that are rich in ores or metals. For example, sulfide minerals are commonly found in volcanic regions or areas of hydrothermal activity, while carbonates are more likely to be found in sedimentary environments. The mining of non-silicates often requires specialized equipment like sluices, drills, and sometimes even explosives, depending on the depth and hardness of the material. Exploration techniques. Exploring and digging for these minerals requires a combination of geological knowledge and practical skills. Here's how to go about it. Research and mapping. The first step is to research geological maps and consult local mining records to identify areas that are likely to contain silicate or non-silicate minerals. Learning about the rock formations in a region helps you pinpoint potential sites. Field work and sampling. Once you've chosen a site, you'll want to collect samples of rocks and minerals. This can be done by hand, using basic tools, or with more advanced machinery depending on the terrain. Pay attention to rock types, color variations, and crystal patterns that indicate the presence of valuable minerals. Extraction and processing. After locating mineral deposits, careful excavation is required. For silicates, the extraction might involve breaking apart large rock formations, while non-silicate mining often requires digging deeper into veins. You'll need to process the minerals to remove impurities, sometimes using flotation, grinding, or chemical treatments. Safety and environmental considerations. Always ensure that you follow safety protocols when mining. Working with minerals can involve heavy machinery, chemicals, or even explosives in some cases. Moreover, responsible mining is crucial to prevent environmental damage, such as habitat destruction or water contamination. Let's dive deeper into the exploration and excavation of both silicate and non-silicate minerals, their applications, and the techniques used in their discovery, processing, and mining. There's a lot to unpack in both these categories, especially if you're keen on learning about all aspects of mining and mineral exploration. Silicate minerals. As mentioned before, silicate minerals are incredibly abundant and make up most of the Earth's crust. They are essential in geology and mining because they often provide clues about the environment's past and can yield precious resources. Silicate minerals play a critical role in industries like construction, electronics, jewelry, and even agriculture. Formation and occurrence silicates are formed primarily in igneous, sedimentary, and metamorphic rocks. They tend to occur in crystalline forms that are easy to recognize once you know what to look for. The variety of silicate minerals is vast, with over 90 distinct species, each with its own unique properties. Key silicate groups, tectosilicates, framework silicates. These include quartz and feldspar, which have a three-dimensional framework structure. Quartz is the most abundant mineral on Earth, found in granite, sandstone, and various other rocks. Feldspar is used in ceramics and glass making. Phyllosilicates, sheet silicates, mica, talc, and clay minerals belong to this group. Mica is often found in igneous and metamorphic rocks, used in electronics and insulation. Talc is the softest mineral on the Mohs scale, and is used in cosmetics and as a lubricant. Inosilicates, chain silicates, minerals like amphibole and pyroxene which have chain-like structures. These are found in volcanic rocks, used in the production of heteroresistant materials. Cerosilicates, double-chain silicates, epidote and vesuvianite, belong to this category and are often found in metamorphic rocks. Epidote can be used as a gemstone. Cyclosilicates, ring, silicates, tourmaline and beryl are examples of this group. Beryl includes some important gemstones like emerald and aquamarine. Mining techniques for silicates. Silicate mining often involves extracting minerals from rock formations using drilling and blasting in large-scale operations. For example, quartz and feldspar are often extracted from granite quarries, while mica is sometimes extracted through open-pit or underground mining. Open-pit mining, often used for silicate minerals found in large flat-lying deposits. This method involves removing layers of earth to access the mineral beneath. Underground mining. For deeper deposits of silicate minerals, this technique is used. Miners access minerals by creating tunnels beneath the surface. Flotation and chemical separation. To separate silicate minerals from surrounding material, flotation techniques may be used, where chemicals are added to a slurry of crushed rock to separate the valuable minerals. Uses of silicates. Quartz. Used in electronics, for example, quartz watches, glass making, and construction. Feldspar widely used in ceramics, glass production, and even as fillers in paints and plastics. Mica, important in the electronics industry for insulation and in cosmetics as a shimmer ingredient. Talc used in baby powder, cosmetics, and as a lubricant in industrial applications. Non-silicate minerals. Non-silicate minerals are far less abundant than silicates, but are just as important in mining, offering a variety of industrial, economic, and technological applications. Each class of non-silicate minerals has unique properties that make them valuable for specific uses, such as energy production, metal extraction, and even in the creation of advanced materials. Formation and occurrence. Non-silicate minerals can be found in a variety of geological environments. For instance, carbonates are commonly found in sedimentary rocks like limestone, while sulfides form in hydrothermal vein deposits and are associated with volcanic activity. Non-silicates are essential to industries such as metallurgy, chemicals, construction, and even medicine. Key non-silicate groups. Oxide. These minerals are important because they contain metals that are often mined for industrial applications. For example, hematite and magnetite are iron oxides that are the primary ore of iron. Corundum includes precious gemstones like rubies and sapphires. Carbonates. These minerals include calcite and dolomite. They are crucial for cement production and as flux and steel. Sulfides. These include pyrite, often called fool's gold, and galena, the primary ore of lead. Sulfide ores are often rich in valuable metals, like copper, lead, zinc, and silver. Halides. These include halide rock salt, which is used in food preservation and in the chemical industry. Fluoride is another example, used in the manufacture of fluorine gas, and as a flux and steel. Native elements. These are metallic minerals that exist in pure elemental form. Gold, silver, and copper are examples of native elements. These metals are extracted through simple mining and refining processes because they occur in their pure state. Mining techniques for non-silicates. The extraction of non-silicate minerals often requires specialized techniques, because many of them are found deep underground in concentrated veins.